Hey everyone, this is question 8 of the multiple choice of the 2018 Software Development exam. So this one's about the appropriate use of our data structures. So I've got a few notes down here just to explain each of these choices that we could make. So a string. So a string is a collection of our ASCII characters. So remember, ASCII characters can either be letters, numbers, or special characters. So I've just got a little example of what it might look like if you were to draw one out. Now typically each character is stored in an array, but a string itself is a data type. It just uses that data structure. So for each character is an element in that array, including special characters and also spaces as well if it's a really long one. Our next choice is our array. So it's kind of similar to our string as well, except for it's a bit more broader because you can store numbers. It can be integers as well, floats, booleans, any other data type that you can think of. The thing here is that arrays have to be the same data type. So just keep that in mind there. It has to be the same data type. So the next one here is our record. So they can store related data as well as their data elements. You might know these as fields. They describe what type of data is being stored. So the data in a record doesn't have to be the same data type. So we've got a bit of freedom there. I've just got a bit of drawing of what that might look like. Each one of these here, first name, last name, date of birth, these are our fields. And our data that we could store in there would be something like Larry would be a data for our first name, Larry Jensen, last name. That's another piece of data as well. The last one is our two-dimensional array. So they're very similar to our arrays, our one-dimensional array up here, our normal array, except for we're stacking even more arrays on it. So think of it as an array on top of an array. And here's an example here of a 3x3 array. You can think of these as matrices if you're doing maths. So you can store pieces of data in here. Each square, you can store a piece of data. And just like our normal one-dimensional array, these also need to be the same data type. So now I've gone through a little bit of this here. I'm going to go through the question now. So Huey is writing a software solution to support administrative staff in a school. The software solution must store the details about each student in a school. So every student, there might be 200 students, there might be 1,000 students, but each student has to have all their details stored. The most appropriate data structure to store a student's first name, last name, date of birth, home address, and telephone number is. So I've briefly gone through each of these data types, so we'll go through the answers around here. So a string could store a student's first name, last name, date of birth. It could store all of that, but it'd just be one massive long string, which isn't good if you're trying to search just for the first name or just for the last name. It makes it very difficult for the computer to see. So it's not really a good data type to store it isn't a good data type to store. It isn't a good data type to store information. It isn't a good data type to store data that's grouped together or could be sliced apart if you want a particular first name, last name, etc. So we're not going to go for a string. So next one, let's have a look at an array. So an array could be good if we're just storing our students' first names, but it does break down a bit because we're storing multiple pieces of information as well. So if it was just first names, we could probably put Larry, Gary, Barry, each one of them as well. But once we've got all our first names, there's no room to put our last names or date of birth. So it's not quite what we're looking for here. The next one is a record. So this one's looking a bit promising. Even the example kind of shows it as well, if that gives you any hints. So a record a record stores groups of data about a particular object or something. So we've got students, a student could be our object, and we're storing related data for that student. And the good thing about records is that the data doesn't have to be of the same type. So student name would be a string, last name probably stored as a string, date of birth, you might store that maybe as a string, it could be a number, could be a date data type as well. It's much easier if you store dates as a number or a date though, because if you're storing it as a string and you want to do some calculations on it, say is this date before that date, then you'll have to turn it into a number anyway to do those sorts of calculations. So it's not a good idea to store dates as a string. So home address, that could be a string as well. And telephone number sometimes could be a string if you've got things like dashes or brackets in there. Otherwise, it's usually just stored as a number. So we've got a mix of data types that we need to store. So this is a very promising looking one, a record. And we'll just go through the last one as well. So a two-dimensional array, a 2D array. These do have room to store our student's first name, so we could store a student's first name here. So just do F first name in here, whole bunch of first names, and it has room to store last names. So L does have room to store dates of birth. So it does look promising, and you can obviously expand that to have 3 more down for as many number of students. So it doesn't have to always be a 3x3. It can be as big as you want or as big as your computer hardware allows you. But the thing here is that the data stored in a 2D array must be of the same data type. And we do want that flexibility of having different data types. So that's why we don't pick our two-dimensional array here. So in the end, our answer is a record.